Hello everyone. This is the first of a series of videos dedicated to the chemistry of troposphere. Specifically, we're going to be looking at two processes, the formation of smoke and acid deposition. We will be looking into the different types of smoke, and we will be looking at two types of smoke. Sulfurous smoke, which is also called classic smoke or winter smoke, and photochemical smoke, which is sometimes called summer smoke. We're going to specifically be looking into the chemistry of photochemical smoke into a bit of detail and the key reactions that will bring about a photochemical smoke episode. We'll also be exploring acid deposition, the chemistry of rain, snow and fog, and the composition of natural precipitation and the effect of various processes, anthropogenic sources of various chemicals into the composition and pH of that natural precipitation. We will focus in two acids, nitric acid and sulfuric acid, the production of nitric and sulfuric acid in the atmosphere and the removal of nitric and sulfuric acid in the atmosphere, and the effect of on the pH of rain that both acids have. As usual, the topic will be divided in several videos to make it easier to follow. So what is smoke? Well, it's a mixture of smoke, particles, and fog. It's an air pollution problem, and it is you can see several photos here of different cities across the world, and that sort of haze that you can observe in the pictures. And that haze is produced by a mixture of tiny solid particles of chemicals and also liquid droplets of aerosols that combine, obscure visibility and give that sort of haze to the environment, to the atmosphere. It's not a new problem. It started being a real issue in when the Industrial Revolution came about. But even before it was an issue, and if you can see here this quote by John Evelyn, already writing in 1661, that smoke in London was hell upon earth. And there's also in this slide a picture of a very famous painting by Monet, The Houses of Parliament, in which the painter captured the pea soup smoke haze that was almost permanently over London, especially in the winter months. There are two main types of smoke. One is the classical smoke, sulfurous smoke, the other one photochemical. What is sulfurous smoke? It's sometimes called winter smoke because it tends to be associated with winter, and that is because it's very based on the burning of coal. Especially coal with high levels of sulfur. And the particles are a mixture of carbon soot and sulfur dioxide particles. It has reducing properties because carbon is a reducing agent, and it has acidic properties because sulfur dioxide is an acidic gas. It forms fog and condenses particles of water around those particles of soot and the sulfur dioxide gas, and induces the fog. It's associated again with the burning of coal. So both industrial uses, say power plants depending on coal, especially high coal with high levels of sulfur, which tends to be cheaper. And also it's also associated with household activities, fires. There are still many episodes of sulfurous smoke. Not so much in the UK. Probably the most famous one was the one in 1952 that is associated with 4,000 deaths over the 3-4 days it took place in December 1952. Some authors put that death toll a much higher rate. And that brought about quite a few pieces of legislation in the UK to tackle the formation of sulfurous smoke. And the power plants, for example, that were burning coal were taken out of the city of London and into the outskirts. and smoke and open fires were banned in London. There were still some sulfurous smog episodes after the 1952 event throughout the 60s, but in a much smaller scale. And it was not only a problem with London, other industrial cities in the UK, Liverpool, Manchester, Leeds, also had frequent episodes of sulfurous smoke in the winter because of this association with burning more coal because it was cold, and the humidity in the air and the cold wind, the cold temperatures, that meant that the particles of soot and the sulfur dioxide gas could not dissipate. So lack of wind, high levels of carbon and sulfur dioxide in the atmosphere, high levels of humidity can be the perfect recipe for an episode of sulfurous smog. It's not an issue in the UK anymore, but quite a few other areas around the world which are still very dependent from coal and coal with high levels of sulfur still have problems with sulfurous smog. The other type of smog is what is called photochemical smog. Sometimes it's called summer smog or even LA smog, Los Angeles smog, because it can be quite common in that particular city. Photochemical smoke is associated with the incomplete combustion of petrol, and is very, very strongly associated with car emissions. Industrial emissions too, but traffic it can be a huge a source of the chemicals that produce photochemical smoke. Sulfurous smoke was a reducing smoke. It had a reducing character because carbon is a reducing agent. Photochemical smoke is an oxidizing type of smoke. It has quite a few chemicals in its composition that are strong oxidizing agents, and it's associated with carbon-containing compounds, unburned hydrocarbons from the incomplete combustion of petrol, nitrogen oxides, and the production of ozone in the atmosphere, in the troposphere. It's associated in the UK. It's associated with the summer, long days, and because it has this photochemical aspect. It needs the solar radiation for the reactions to occur, for the photochemical reactions to occur. It's associated in the UK with the summer, long days and no wind conditions and high temperatures, and it is a problem in quite a few cities across the world. Some of them are quite famous. Los Angeles is very famous for its haze associated with photochemical smoke, but it's not the only one. Mexico City, for example, another area which has huge problems with photochemical smoke. So what are the health effects of smoke? The health effects are quite varied and can result in an increased susceptibility. There are direct effects like airway inflammation or loss of lung function or shortness of breath, cough, eye irritation, and that's due to the reducing and oxidizing properties of the smoke, reducing in the case of sulfurous smoke and oxidizing in the case of photochemical smoke. It increases the susceptibility to infection, and it can increase the number of hospital admissions in a country, and eventually it can cause death. Worldwide, the World Health Organization suggests that around 4.2 million people across the world die every year as a result of living in in areas with poor air quality. And in the UK, the Royal College of Physicians suggests around 40,000 deaths in the UK every year are associated with outdoor air quality. Those more at risk are the elderly, children, and people with pre-existing conditions. There's also some association of living in an area with high air pollution levels and problems during pregnancy, especially a low birth, the birth of low-weight infants. So it is a huge problem, both worldwide and specifically in the UK.